Let's try to figure out this type of diagram. When can we have this type of diagram in Mathematica? So for that we require some prerequisites. The prerequisites are namely, we should know that r equal to a cos theta is a polar equation of circle touching y-axis and having the center on x-axis, and r equal to a sin theta is the rotation of the same by 90 degrees in the anti-clockwise sense. So let's plot this and then step by step develop the diagram. So we'll have polar plot r equal to, so my first equation is the equation is a cos theta. For theta I will use th, and I have to specify the range for th. Theta will go from range from 0 to 2 pi. So a is to be specified. Let's take a to be 3, and then I'll shift enter. I will have a plot. So this is the plot that I get. So if I take the radius to be, this is the diameter 3 actually. Now if I take 4, then the diameter of the circle becomes 4. If the diameter is taken to be 2, then the diameter will become 2. So if I take a sine over here, SI and sine, then I get a circle on the y-axis, positive y-axis. So the thing is, I want all the family of circles which lie on the x-axis. So I want a, I want this, we want this cos theta, and we want a to change. We want this a to change also. So what I will do is I will plot table of this where a will change. A will range from, we can take it as 0 to 3 with a distance of step size of 0.5, with a step size of 0.5. And then we shall evaluate this at theta from 0 to 2 pi. So this table is the list that we are providing. So there are many graphs in this, many equations in this. For every value of a, for each value of a, it will execute this command, and we will look at this. So we got family of circles. We are getting family of circles on the x-axis. But the thing is, we want it on the negative x-axis also. So a should be, instead of r equal to a cos theta, I should have the equation as r equal to minus a cos theta. So that I will choose the value of a to be minus also. So I will have minus 3 to plus 3 with a step size of 0.5. So when we execute this, we have a graph like this. I can increase the number of iterations. So the number of circles in the family, number of members in the family increases. So we don't want this axis also. So what we do is we can have axis in the plot style. We can have axis to be false. So the axis vanishes and we just have this beautiful diagram. Now we want the same thing to happen with the y-axis also. So we'll call this as pick 1. Pick 1 equal to shift enter. We get this. Similar thing can be copied down again. Control C, and I'll say Control V. I'll have it as pick 2. Instead of cos, I will have here as sine, shift enter. So what I get is 2 figures. What we get is 2 figures like this, horizontal and vertical. Now we want both of them to happen in the same axis. So I will make a semicolon over here to suppress the output, and I will use the command of show to paste both the picks together in one. So pick 1, comma, pick 2 and shift enter. So we get both the commands, both the figure overlapped in the single frame. So this is what we have. Now we change the color of the circles. For the second one, we'll say plot style. Plot style, we'll take it as magenta. Shift enter. Execute this and we get this type of figure. So now we got 4 figures, 4 circles, 4 family of circles. Now we want the output to look like this. Very easy. What you have to do is some changes in this. Let's say copy. Just observe this. We have to just do shifting over here. This circle is to be shifted by some degrees, and this circle again is to be shifted by certain degrees, equidistant. So we'll have 3 picks, 3 families. I'll pick 3. So I will have a pick 3 also over here. Control C. I'll say Control V. I'll paste this 3. Color, let's take it as, choose it as magenta is done. Let's take it as orange. And let's have here as cos theta, a cos theta, theta plus 30 degrees. And similarly over here, cos theta plus 60. I hope you know what we are doing, what we are up to, right? So I hope this works. If it doesn't work, we have a second plan. So shift enter. So it looks like this. So it still doesn't work. So what is the problem? The problem is of rotation. We are not rotating it by the correct angle. So the correct angle will be 60 and 120 degrees. Shift enter. Let's look at the output. Oh yes, that's it. So we can choose beautiful colors. We already have this. Instead of orange, we can have it as green. What about green? Shift enter. Or red will look a little darker. Shift enter. So using this rotation concept and the polar equation curve of the circle, we are successful in getting or drawing this beautiful curve using the table command of Mathematica.